Number 11, we need to start by isolating the absolute value expression. I think I mentioned this on Friday, but I will reiterate it. Do not combine the 9 minus the 4. Okay, that is not your first step to do 9 minus 4 right there, because the 4 is being multiplied by the absolute value expression. So instead, we need to start by subtracting the 9 from both sides. That is step number 1. Subtract the 9 from both sides. So we've got negative 4 times the absolute value of c plus 10 is equal to negative 24. Then we divide both sides by negative 4. So it took us 2 steps to get us there, but that is step number 1 in our steps. We're always isolating, trying to isolate the absolute value, so we have done that. After we isolate it, then we split it into our 2 cases. So the first case, remember, we just drop the absolute value, nothing changes. The second case, we drop the absolute value, we change the sign of what's on the opposite side. So that is equal to negative 6 now. Then we solve them individually for c. We subtract 10. 6 minus 10 is negative 4. Subtract 10 on the other one. C is equal to negative 16. We always want to check our answers. We can do that one of 2 ways. I'll do it using the calculator this time. Next problem, I will check it using the graph. So let's remind ourselves where this is at. We're typing in the original equation, 9 minus 4, the absolute value. Second 0 is the easiest way to get there. Second 0 is the easiest way, and it's the very first option. Let's plug in the answer of negative 4. We're wanting it to be equal to, oops, I did minus and not plus 10. Okay, that did work out correct. We want it to be equal to negative 15. When I saw that it was initially not equal to negative 15, I looked really quickly back at the problem and made sure that I didn't type anything in wrong. I did. I put minus 10 instead of, it should have been plus 10 to get us the correct answer of negative 15. So negative 4, bless you, negative 4 checks out. That is one of our solutions. Let's check negative 16 as well. 9 minus 4, absolute value, negative 16 plus 10. And that also gives us negative 15. So both solutions check out. Any questions about the steps there? All right, let's look at number 13. Nothing's different about number 13 except for the fact that we have a variable on the other side as well. The variable is not only located inside the absolute value bars. Now with this one, it is isolated from the get-go. There is nothing outside the absolute value on that side, so we go ahead and jump to 2 cases. So first case, absolutely nothing changes. We just drop those absolute value bars. Second case, do not change what's inside the absolute value. You change the other side. Now, there's more than one term on the other side. So we will change the sign of both x and change the sign of the positive 1. So notice it's equal to negative x minus 1. Anytime there's more than one term, you change the sign of all the terms. Now, variables on both sides. There are a couple of different ways that you can handle these equations. In my opinion, it is best to move the variable first. Move the variable first. So we've got 3x on the left side and we've got an x on the right side. Move the smaller one. So that means we're going to subtract x. So we get 2x minus 9 is equal to 1. Then we move the number. Add the 9 to both sides, so 2x is equal to 10. And then finally, we can divide by 2, so x is equal to 5. Now, in the second equation, similar scenario, I'm going to move the x, but this time it was a negative x. So this time I'm going to add the x to both sides. So 4x minus 9 is equal to negative 1. I still add the 9, but I'm adding it to negative 1. So 4x is equal to 8. And then I divide both sides by 4, so I get that x is equal to 2. Now on these, if you're plugging into the calculator, you've got to plug in both sides. Okay, I've got to check 3 times 5 minus 9 inside the absolute value bars. Now, hopefully you really don't need to plug in 5 plus 1 into the calculator. If you do, if you're worried about it, go ahead and do it for security's sake, but I think we know that that is equal to 6. So x equals 5 checks out. And let's check x equals 2. And 2 plus 1 is 3, which is what the left side of the equation equals when x is 2. So both of those solutions check out as well. Now notice we got different values when we plugged in the different answers, but that's okay. It's just the left side has to equal the right side when we plug in x equals 5. The left side has to equal the right side when we plug in x equals 2. They don't have to be exactly the same value. It's just left side has to equal right side. Let's do number 14. 2 times the absolute value of h plus 8 is equal to 14h. So this one we need to start by isolating. We do not distribute the 2. You got to move it to the other side. So we have to start by dividing both sides by 2. You never, ever, ever change what's inside the absolute value bars. Okay, so divide by 2. That means the absolute value of h plus 8 is equal to 7h. Now we split it into our 2 scenarios. First scenario, keep everything the same. Don't change a thing. Second case, change the sign of what's on the other side. So it's equal to negative 7h. Now we solve. So in this case, subtract h. 8 is equal to 6h. And we divide by 6. So 8 over 6 is what? 4 over 3. I do not want that decimal value. Use the fraction. If you don't know how I reduce that without the calculator, then go to the calculator. 8 over 6. You know that doesn't divide evenly. So just go ahead and math enter. Turn it to a fraction. 4 over 3. Okay, now, with the second equation, usually in this case, I would add the 7h, but since it's already on the side by itself, I'm going to just suck it up and deal with a negative variable because it was already on the side by itself. I subtract h from both sides. So 8 is equal to negative 8h, and divide both sides by negative 8, so we get negative 1 is equal to h. We want to check both those answers. 4 over 3 plus 8. That should be equal to 14 times 4 over 3. We get the exact same decimal value. So 4 over 3 is acceptable. Let's check negative 1. Absolute value, negative 1 plus 8. So it should equal positive 14, but 14 times negative 1 is not positive 14. So this is what we call an extraneous solution. I don't want you to erase it. I don't want you to mark it out. If you run into an extraneous solution, leave your work, leave your answer, and write extraneous solution beside it. I would not be surprised to see one of these as a question on the exam where they ask you to like drag and drop. They'll give you answer choices, and I could see them having a column for solutions and extraneous solutions. So if you run into that case and you're doing this problem, then you would take the answer choice of 4 over 3, drag it into the solution box, and -1 would be an extraneous solution. Now, there will be other answer choices, but they just stay where they're at because we didn't get them as an answer. They were not a solution and they were not an extraneous solution. So you got to know where that comes from to be able to answer a question like that correctly. Okay, let's look at a couple more of these, and then I will turn you loose on some practice. Number 15, absolute value of 8 minus 2n minus 5n is equal to n plus 2. So we've got to start by isolating the absolute value. We need to add the 5n. So we have the absolute value of 8 minus 2n is equal to 6n plus 2. Absolute value is by itself. So 2 scenarios, 2 cases. First one, nothing changes. Just drop the absolute value. Second one, drop the absolute value, change all signs on the right side. So that becomes -6n minus 2. Yes, I'm being very repetitive in the things that I'm saying, but I firmly believe that the more you hear it, the more you think it, the more you do it, the more likely it is to stick. So I will say a lot of things repetitively in this class. 8 is equal to 8n plus 2. So then we subtract the 2. 6 is equal to 8n. Divide by 8. 3 over 4 is equal to n. For the other equation, I'm going to move the variable to the other side. Because if I add the 6n to both sides, I'm going to get rid of those negative variables. -2n plus 6n is positive 4n. And we subtract 8, so 4n is equal to -10. Then we divide by 4. N is equal to, that would reduce to -5 over 2. Particularly when you get negative answers, it is not a guarantee by any means that it's going to be extraneous, but there's a better chance that it's going to be extraneous, but you still need to check both answers. So plug in 3 over 4, make sure you close your parentheses before you do the -5 times 3 over 4, and then 3 over 4 plus 2. We get the exact same decimal, so 3 over 4 is a solution. I would suggest, let me show you one more time what we did on Friday, storing something as x, -5 over 2. I'm going to store it as x so that it's easier for me to plug that in to my equation. I don't have to type in the -5 over 2 every time it shows up in this equation. So I get 25.5, and then x plus 2 is not equal to 25.5. Now, if you run into that, first thing that I would always do is I would always look, as I mentioned before, check to make sure that you didn't type something in wrong. Make sure you've got all your signs correct. Make sure you got parentheses where you need them. Don't automatically assume that it's extraneous just because you didn't get the same values. Do a quick double check before you identify that as extraneous. Okay, but if it does not have the same value, you will plug it into the original. Again, go to the original. Don't go to any of your intermediate steps. It might work there, but it's got to work in the original to be the actual solution. Y'all need to see another one like that, or are we good? Good. Okay. Let's, I do want to show you this last one, checking it by graphing, because I hadn't shown you any of those. So let's look at this one really quickly. The absolute value, that's not what I wanted. 8 minus, don't put the weird letters in there, okay? Always use x instead of, in this case, n, 2x minus 5x. Okay, we plug the left side in, and then we plug the right side in. Okay, so that's the left side of my equation. This is the right side of my equation. Right off the bat, I see one intersection there at 0.75. Well, guess what 0.75 is equal to? 3/4. So that confirms that answer. And then we're used to two solutions, right, with these absolute value equations. So I'm going to zoom out to see if I can find another one. And I can see, as I'm examining the graphs here, that these are never going to intersect again. If you look at this red graph, that's the piece that has the absolute value in it. We're expecting absolute value to look like a V. Bless you. This one has a little bit of a V in it. It's not like we're used to them looking, but if you kind of look at this, you can see that the slope definitely changes about in this point, but it's still headed downward. It's not going to bounce back up so that it can intersect this blue line again. So there is only one solution to this problem, and the extraneous solution doesn't show up. You have to know how to do it this way to find the extraneous solution. It is not going to show up on the graph. Only the true solutions will show up on the graph. Questions about that?